This is the lecture video for short-term changes to the Earth. The content page is that title. And I'm going to go pretty quick, but remember, it's a video. You can pause and rewind. You can slow this playback speed down, whatever you need to do to get it. But I don't want to make this video too long, so I'm going to keep on moving. When we talk about short-term changes, there's a lot we can talk about. But for our class's purposes, we're going to talk about a few things like seasonal weather changes, some extreme weather that happens from seasonal weather changes, solar cycles, and some natural disasters. Now, these things happen quick. Within a year, sometimes they happen multiple changes in a year, or a couple decades, but certainly not more than like 100 years. The first one we'll talk about is seasons, but I did go over this in great detail in the Energy from the Sun content page lecture video, so go back to that if you don't understand this. I'm going to assume that if you're watching this video, you already know that stuff. So an overview, essentially the weather changes for each region or hemisphere of the Earth like 4 times a year. Since the Earth is on a tilted axis, its axis is tilted about 23.4 degrees, there are certain times of the year where a particular hemisphere is pointed more away from the sun or more towards the sun. Now, this changes the amount of direct solar radiation hitting that part of the Earth, and it makes the days and nights different amount of times, which leads to different kinds of weather in that area at that particular time of the year. All right. Double check that previous video if you need more about that. Now, sunspots. We learned this in Unit 1. We know that there is an 11-year cycle. The sun will reach a maximum where there are more sunspots, more activity, more solar flares, more coronal mass ejections. And then there is a lull, kind of minimum part of the cycle where there are less sunspots, less activity. Now, some people try to equate climate change to this, that these solar cycles affect the climate long term, but the general consensus is that they don't. However, in any particular year, if during a solar maximum there are more coronal mass ejections or more solar flares, it can cause some changes. It can interfere with some of our electronics, anything that deals with magnetic fields. Also, it can change the auroras. If by a freak chance, a huge coronal mass ejection blasted on Earth, it could have some serious short-term changes, but not for climate at least. So natural disasters, we'll use a volcano for this. Volcanism can have drastic short-term effects on the Earth. If a volcano erupts, it also erupts things like ash, carbon dioxide, sulfur. That CO2, if it fills the air, can increase the amount of thermal energy absorbed and held in the atmosphere, which can increase temperatures. The ash can be like a huge black cloud. If a volcano erupted for like 30 years, which is very unlikely, but if it was a serious eruption for that long, then potentially that ash could kind of block out the sun in that area, maybe even a huge area, right? Especially if it gets really high above where it rains, it won't really come back down to Earth that quick. That could affect the plants because plants use the sun for photosynthesis. Also, some sulfuric substances can mix with water vapor and they can make really reflective particles in the sky, which can reflect solar radiation back out into space. We talked about how solar radiation is reflected on the Earth and absorbed. So the sulfur particles can increase the reflection of solar radiation back out, which would reduce the energy we get. Now, here's what I want to talk about weather. We'll say El Niño, which is something that happens in a particular part of the Earth. But before we got there, we have to talk about the Coriolis effect. Now, I'm going to simplify this. You learned this in middle school, but I'm going to simplify it just so you understand that there are consistent, reliable weather patterns, wind patterns that happen on the Earth. We can expect wind on the surface to be blowing from the east to the west, call them the easterlies, near the equator, and the opposite above that. We're not going to go too much into detail about every single specific type of cell, but in general, near the equator, we get winds that blow towards the west. Why? Well, imagine we're looking at air over the Earth. We know that the equator, which is dead center on the Earth, is the warmest part. It gets the most direct sunlight throughout the whole year, most consistent solar radiation. So imagine the air above the equator. That's going to be warm air rising. Remember the convection currents we did? Warm air, as it heats up, expands and rises as it floats on top of other air. As that air rises, let me draw this. Let's take a step back. Equator is warm, the North and South Pole are cold. As this warm equatorial air rises, air over the equator gets hot and rises, it will have to be replaced by other air, so cool air from the north and from the south gets drawn in. As that cool air gets drawn in, it has to be replaced. That warm floating air or rising air, as it's cooling, going away from the equator, that will sink and be replaced and replace that cool air, and itself will become cool air. So you might notice this looks familiar. Rising warm, going towards a cold region, cooling, sinking, going towards a warm region, cool air warms up and rises. We have convection currents right here. Now, what we're going to look at for this example is these surface winds here. Let's look at the surface winds. You would expect that we get cool wind that blows from the north towards the equator because of these convection currents, and from the south towards the equator. So we could think that the Earth has consistent wind that blows from north and south to the equator. However, the Earth is spinning, and that changes the way that these winds move. Since the Earth is spinning this way, or I could say around this way, right? What happens is we have a difference in speed that the Earth spins in different parts of the world. Well, what do I mean by that? If you live up here in the north and you took a plane around the Earth, it's a much shorter distance than if you lived near the equator and took a plane around the equator. You'd have to fly more miles around the equator because it's thicker at the equator, the Earth is thicker at the equator, and less miles further north or further south. Since the whole Earth spins as a uniform body, it spins all together, it's covering more ground in its spin over the equator, so it's going faster at the equator, slower at the closer to the northern and southern poles. So what happens is that wind that's going straight down, since it originates here closer to the north or to the south, we could do either, it's actually moving slower, and it sort of gets left sort of behind as it goes towards the equator, since the equator is moving faster. And what that does is it gives us surface winds, the cooler winds, that blow towards the west, from east to west. Now, this is interesting if you like history, because they call these trade winds, because as explorers sailed from these countries here over to the New World, they could use these winds to establish trade routes or to get to places quicker. But that's not for my class. That's the Coriolis effect. Now, from that, we can talk about El Niño. So, since the wind usually blows near the equator towards the west, what happens is the wind will blow the surface water, since it's blowing across this big, huge Pacific Ocean. It'll blow that warmer water that's at the surface of the ocean over towards here, this part of the world, right near Australia. Now, in a normal situation, when that happens, it can make certain weather that's reliable in certain parts of the world, right? Rising moist air will have high rainfall, right? Descending drier over here. However, one other short-term change to the Earth that happens is sometimes those trade winds, those reliable winds, slow down. Sometimes they can even reverse. But when they slow down, if the winds change on the planet, El Niño is a good example, this reliable rising moist air over here near Indonesia and Australia, that won't be as far over, and it can actually get pushed somewhere towards the middle, and it can change the temperature of the oceans in this area. This counts as a short-term change. This can change weather. It can either result in wetter, warmer weather on this coast, or wetter, warm weather on the opposite coast. These are the short-term changes that can happen to Earth that we're going to focus on in this unit. If you need to rewatch the video, rewind it, pause it, slow the playback, or ask me a question.